Alrighty, so today we're going to be talking about measures of center and spread. So you're going to be able to calculate the measure of center, and then you're also going to be calculating the measures of variability or the spread, how far everything varies, two different ways. So the first thing we take a look at is measures of center. So there are three types of measures of center. When we talk about the center of a distribution, we really are talking about when we try to look and use one value or one number to summarize the data, which we've kind of talked about our typical values. Normally we take a look at the most frequent, but the most frequent isn't always the center, so we're going to look at other ways to actually measure and calculate those measures of center. And sometimes one is better than the others, and you've heard of these three words, hopefully, before. The first one that we're going to talk about is the mean. The second one is the median. The third one is mode. So mean, median, and mode are the three ways that you can calculate the measures of center. Now, notice how there's no average when we're talking about the center, because the word average is just a generic term in the measure of center in and of itself. So usually when we talk about average, we refer to the mean. So make sure that you're looking at actually just talking about the mean of the data set or the median of the data set. We don't want to say the average of the data set. So we have a data set here, and we're going to take a look at mean first. So we'll look at the data below, and this shows the ages of a random sample of 24 teachers at our school. And we have all these different ages. And so the first way that we're going to do is actually finding the mean. So remember, in order to find the mean, all we really do is just add up the numbers. So we're going to add the numbers together. And we're going to divide by the number of observations. And when I say number of observations, really what that means is that really we're just taking and dividing it by the total number of people in our group. So our total number of observations would be 24 because those are 24 teachers. All right. Now, there is a very specific way. It's going to look really complicated, lots of symbols involved with finding the mean. We need to know these because when we're going to look at our TI-84s, some of these symbols are going to start popping up, so I'm going to make sure that you're familiar with them before we start looking at everything. Now, because it's a sample, we're going to do our sample mean, which is x bar, is going to be equal to, and really to put sum or add all together is going to be something called the sigma. And we have xi, and that's of each observation. And we're going to divide that by the number of observations, so n. So once again, the mean of the sample is going to be x bar. Each individual observation is x sub I. The number of observations is n. And the capital sigma just means add up to or the sum of. So now let's actually talk about the mean age of the teachers and calculating that mean. So to find x bar, is what we call it, we're going to take our summation of all of our individual observations. So we're going to take the sum of each individual observation, and we'll divide by the total number of observations that we have. So looking here, we have 33. We're going to add 25 plus 45 plus 31 plus all those in between, and we add them up all the way up to 32, which is the last observation. We're just adding them all together. And once we add all those together, we're going to start dividing it by the number of observations. But we already talked about how there were 24 observations. So we're going to divide it by 24 teachers. So when I add all my values up, I should get 820. And I'm going to divide that guy by 24. When I do so, I get 34.2. So we can see that the mean teacher age at our school is 34.2 years. So Notice I put mean in there, not average. So make sure when we start talking about mean, median, and mode, we're talking about no average. It's just the mean is what we're talking about, because that way it tells us what we're calculating in the grand scheme of things. All right, so sometimes we don't always use a mean to describe the center. And the reason why we don't use mean to describe the center is because sometimes we have outliers. When I talk about outliers, it means that it lies way outside the abnormal distance and the other values. So it's something that's way far out there, like way too high or way too low. And usually you have two mathematical ways of determining if the value is an outlier, which we'll discuss here later on. But for now, we're just going to look at an example of an obvious outlier. So looking at our student scores here, we have 7 exam scores where we have 90s and 80s, and then we have the 0. Way below average. It's way outside the normal. So we're going to make sure that when we're looking at this 0, there could be possibilities as to why we have an outlier and why we might eliminate the outlier. So thinking about if you have like a missing grade in, well, it's because we were sick, or you didn't have enough time in class, or the teacher hasn't graded it yet. So maybe you just needed some extra time when we're talking about looking at outliers. So a legitimate reason to eliminate this outlier in this case is that we could say that they were absent that day and they needed more time to make it up. So that's what you should write there. So if you want to pause the video, you can. So a legitimate reason, they were absent, and we just need time to make it up. And it was an excused absence, if you want to even go that far. All right. If you can't eliminate the outlier, we're going to calculate the mean. So we're going to take a look at what the difference is between eliminating it and keeping it in, so on and so forth. So if we can't eliminate it, I'm going to take 90 plus 92 plus 94 plus 98 plus 86 plus 88 plus 0, and we get 548. And we're going to divide that by our 7 exam scores. And that's going to get me 78.3. So our mean test score or exam score is going to be a 78.3. All right. Now, if you did eliminate the outlier, obviously it's not going to change the sum at all, because the sum, when we added 0 and added in nothing, so we have 548. But now we're not dividing by all 7 of these. We're only going to divide by the 6 that we have actually taken to get a legitimate mean value. And we get 91.3. Notice, what is it doing to the outlier? Or what is the outlier doing to the mean? Well, it's bringing down the mean quite a bit. So what this means is that our mean is non-resistant to outliers, meaning that it can't resist the fact that we have one, and it brings it down. Usually they're strongly influenced by extreme values, which is the reason as to why sometimes we don't use mean in order to have some type of value in there where it's an outlier. It's going to affect it dramatically. So here, what is it doing to the outlier? Well, it's bringing the mean down. Meaning that this is a non-resistant, which is what I just said. It's strongly influenced by extreme values. So if we have extreme values in the data set, we do not use mean. It's going to get pulled towards that value. Because we had a low value in our data set, our mean is going to get pulled down. If we had a really, really high value in our data set, say like we had like all 60s and 70s in here, and then we had 190, the 90 is going to pull that guy up, and it's going to strongly influence our mean. So if we have extreme values in our data set, we do not use our mean. What we are going to use instead is a more resistant value and measure of center, meaning that the extreme values in the data set get ruled out and it actually doesn't affect it as much, which is our median. So our median, remember our median is our middle number. It's the middle value. It's the value in the middle. So I went through and I already organized these from least to greatest. Now remember, when you're doing your median, you got to make sure you have your lowest to your highest value. So we already talked about mean. Our mean value was 34.2. And now I'm going to calculate the median. Now to do so, remember we just kind of tick one off. We're trying to find the middle value. So I'm going to take one off here, one off here, one off here, one off here. And we're just going to keep going. Remember, they have to be in least to greatest in order for you to be able to do this. Now, we have these two numbers here in the middle. Okay, if you have a middle number, or if you have two middle numbers, what you're going to do is, so if you don't have like a single middle number, you're going to take the average of the two. We want to find the middle that's between these two numbers. So in order to find the median, I'm going to make sure that I take 31 plus 32, and I get 63. And I'm going to divide that guy by 2, and I'm going to get the value that's going to go right in the middle. So I'm going to have our 31.5 here. Value that's right in the middle. How do these compare? Well, they're approximately the same. So really, did we have an outlier? No, because we had the 49s and the 40s and the 50s. We had the 20s. We didn't really have an outlier. So really, it doesn't matter what value we use, either mean or median. It's really up to you. When you're looking at this, if you don't have any outliers, I would strongly recommend then going to the mean. If we have large outliers, we're probably going to go with the median because it's not going to be affected, such as looking back at our examples of our exam scores, we have this outlier of 0. Notice our mean value was 78.3. If I'm going to look at the median, so I'm going to take off these, one from each end, and I get my middle score of 90. Well, how do these compare? My 90 is a much better score, right? Closer to my mean without my outlier. My median's much closer and a better representation of our actual center of our data. So what this means is, this isn't saying that every single time that the median's always going to be the better measure. No. Only use median if you have extreme values or outliers. So extreme low or extremely high values, they're called outliers. If you have outliers, so whenever there are outliers, you're going to use the median. If you don't have outliers, then use the mean. The median doesn't necessarily have a formula or a special math symbol. Usually use MED for short, but here there's no really center. You're just kind of taking off one from each end, finding the middle of your data. Make sure it's lowest to highest before you start doing that. Here I kind of already organized it by hand for you. Now, the last measure of center is what I call the most pointless measure of center is the mode. It's the most frequent or reoccurring data in the data set. And we've kind of used mode already. And now that when we have these different types of centers, where we talked about the symmetric or unimodal, now that might actually be the most occurring value that's in the middle. Remember, symmetric's that bell curve, which we'll discuss again. Or unimodal is where we have everything is exactly the same. However, there are different shapes, such as skewed right or skewed left, that when we say that it's going to be the most frequent, it's not necessarily the center of the data. So this is the measure of center. The mode is kind of useless to measure the center. So like, for example, if I had something that looked like this and I had 1, 2, 3, 4, and let's say I had 5 over here. So let's say I had this guy, oops, and this guy. So if I had something like this, I could say maybe, yeah, my center is around 3. That's the most reoccurring because it's a symmetric data set. But if I had something that was skewed, such as 1, 2, 4, is 4 going to be the center of my data? No, it's not going to be the center of the data. It's more so going to be like a 2 or a 3 versus a 4, because we want to take a look at the middle of the data and our typical value that lied between those values. So 4 isn't necessarily the center. I don't like to use mode as a measure of center. Your mean or your median are going to be much more accurate with your values when you have a full data set. So taking a look at that data set again, where we have our teacher ages, we already calculate the mean, which was our 34.2 years. We already calculated the median, which was 31.5. Now, if I wanted to calculate the mode, remember this is the most frequent value. So if you're looking at the most frequent, so we had 225s, we have 329s, 230s, 231s, 232s. We don't have 3 of anything else. So our most frequent value is going to be 29. Yes, that's close to these values, but it's pretty low compared to the other two, especially when we didn't really have any outliers here. And then what if we have 2 modes? Well, if we had 2 modes, then we have a bimodal, and then we have 2. Do we have 2 centers then? If there's no mode, does that mean we have no center? So not necessarily. That's why in stats, mode is not really used to describe center, just because when we're taking a look at all these different pieces, statisticians don't really look at mode. They usually look at mean. So we use mean when we don't have any outliers, and use median when we have outliers. So now we're going to take a look at spread. There are 3 different measures of spread in statistics. We're going to talk about 2 today, and then we'll talk about the other one here in the upcoming lesson. So the first one, so spread, it's how far we typically vary in our data set. And we've actually already talked about one of them, which was range. The second one we're going to talk about is called standard deviation. And the last one is called an IQR, which we're going to talk about in our next lesson. We're not going to discuss here. So range, we've already talked about. It's how far our values vary. And this is a number, not an interval. So we say our values vary this many inches, this much time, this number of years. So if we want to look at years here, we're going to take our maximum minus our minimum, and that's our range of our values. That's how many years span between the teachers. So we're going to take our maximum value minus our minimum value, and that's going to give us our range. Once again, not an interval, just a number. Pretty straightforward. Now, standard deviation is very complicated, and we're going to walk through it. And there's a very long, there's a formula for it, but we're going to walk it through step by step, so that way you know how to do it by hand. Very rarely are we going to calculate standard deviation by hand, but you're going to need to know what the symbols are on the graphing calculator, so that way it can do it for you when you plug in all your data sets. Now, standard deviation is the average deviation observation is from the mean. Think of mean and standard deviation go hand in hand, like peanut butter and jelly. Can't have one without the other. You gotta find your mean in order to find your standard deviation. This is how far we deviate from the mean. So how much do we typically vary away from the mean of our values? So we're going to find the mean and look at how far we deviate left and right from our mean. So for example, we have a group of individuals, an elementary school children. Now we're asked how many pets they have. And here are their responses, arranged lowest to highest for us. Very nice. And so the very first step that we're going to do to calculate the standard deviation, once again, can't have standard deviation because this is how far we are deviating from the mean value. So this is how far we are varying from the mean. And we can say, if you want to, how much we deviate from the mean. So how much our values typically vary from the mean. Vary, deviate, mean the same thing. So we need to calculate the mean. Remember, in order to calculate the mean, we're going to make sure we add up all these numbers and divide by how many there are. So I'm going to add up 1, 3, 4, 4, 4, 5, 7, 8, and 9. And we'll divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. Because we have 9 individuals that were asked. And we're going to get 5 pets. So our average in our class, or out of the group of elementary school children, is going to be 5 pets. Okay. Next thing we're going to do is take each observation, and we're going to figure out how far it varies from the mean. So we're going to subtract it from the mean. So these are all our individual observations. And what we're going to do next is take each individual observation, and we're going to subtract the mean from it. So I'm going to take 1, and we'll subtract 5 from it, and we'll get negative 4. We're going to take 3, subtract 5, we get negative 2. We take 4, subtract 5, we get negative 1. 4, subtract 5, we get negative 1. 4, subtract 5, we get negative 1. We get 5, subtract 5, we get 0. 7 minus 5 gives me 2. 8 minus 5 gives me 3. 9 minus 5 gives me 4. Now, what's kind of cool about the mean is this is kind of a property of the mean. If you add negative 4 plus negative 2 plus negative 1 plus negative 1 plus negative 1 plus 0 plus 2 plus 3 plus 4, you're going to get 0. Because we already calculated the mean, and that's an actual cool property of the mean, is that when you add all these deviations of the mean, you add them up, you're going to get 0 every single time. So we can't just take those values, because every time then it's going to be 0, we're deviating a 0 amount. We're trying to find the average deviation. So what we have to do first, we have to square the deviation. So we're going to take each of these values, and we're going to square it. So I'm going to square each of those values. So I'm going to take negative 4, and I'm going to square it. Now, when I take negative 4 squared, be careful. Negative 4 squared is like negative 4 times negative 4, which is going to get me positive 16. I'm going to take negative 2, square it, we get 4. Negative 1 squared, we get 1. Negative 1 squared, we get 1. Negative 1 squared, we get 1. So remember, negative 1 times negative 1 is not 2 or negative 2. It is 1. 0 squared is 0. 2 squared is 4. 3 squared is 9, not 6. 4 squared is 16. So just kind of putting steps in. Our first step, calculate the mean. Second step, you're going to subtract the mean from every value in every observation. So you're going to figure out how far it deviates. Then you're going to square those guys. So now we're going to compute the average squared deviation. Well, we just squared the deviations. Now we're going to compute the average. So remember, when the average, you add it up and then divide by how many there are. Now, instead of dividing by how many there are, like n observations, we're going to divide by n minus 1. Reason involves calculus. Just trust the process. So looking at how we're calculating this, we have our sum. So we need to add our total up. So we have our sum of our x individual observations minus our mean squared. And we're going to divide this by n minus 1. So if I take each individual, so I take 16 plus 4 plus 1 plus 1 plus 1 plus 0 plus 4 plus 9 plus 16, we're going to get 52. And so we're going to take 52, and I know that we had 1, 2, 3, 4, 5, 6, 7, 8, 9 total observations, but we're going to take a 9 minus 1. That's what we're going to divide by. So we're going to take 52 and we're going to divide this guy by 8. So that's our average. So we have 6.5 is our average squared deviation. Now what this is called, the 6.5, is called the variance. Now variance can be used in other cases, but we're not going to use variance really here because we want to look at our standard deviation instead. So this is just the average squared deviation of the number of pets that this elementary children have. And this is kind of the S sub x squared is the value that we have, and this is the average squared deviation. And we just want the average deviation. When we're trying to look for the average deviation instead of average squared deviation, I would need to get rid of the squared. So how can I undo a square? Well, we take the square root, hopefully, and get our value because we have our squared units here. This is technically like saying this is our average squared deviation. Our units are squared pets, and we just want pets. So we want to square root that to undo it. Once again, this is variance is not something that we're going to really use. We're just calculate it in order to find our squared deviation. So what we're going to do is take the square root. So we have our first step, which is finding the mean. Second step, subtracting each observation from the mean, or subtracting the mean from each observation, squaring it, and then we are calculating our variance or our average squared deviation. And then the last step that we're going to do is take our square root to get back to the correct unit of pets. So I'm going to take our square root, so our variance is 6.5. So it's kind of our fifth and final step. So first step, calculate the mean. Second step, find our deviation. So take our values and subtract the mean from it. Square it. Find those, all of that sum of those values divided by x or n minus 1. And then we're going to take the square root of 6.5. And if I take the square root of 6.5, we're going to get just our s sub x, which is exactly what we want. Just undoing that squared that was up here in the top by taking the square root. And we get 2.55 pets. So really, we're trying to calculate the variance first. This is the variance formula, not the standard deviation formula. So the variance formula was the s sub x squared is equal to the summation of each observation, right, minus our mean. That's what we did. We took those values, we subtracted them, we squared them, we added them all up, and we divided by n minus 1. So remember, symbol for variance is the s sub x squared, and sometimes it's a lowercase s. Sometimes it's uppercase. It doesn't really matter. That's always going to be your symbol for variance. Your mean of your sample is your x bar. Each individual sample is the x sub I, just like it was before. Number of observation is n. We have our capital sigma, which is just our sum. Add up, sum, same thing. So we want to put sum of there. It's our summation. And the symbol for our standard deviation is just our s sub x. So remember, in order to get from our variance to our standard deviation, all we have to do is figuring out how to undo that square. We just got to take the square root of both sides. That's all we got to do. So looking at the standard deviation formula, it's just taking the square root. So we have s sub x is equal to, we're taking the square root of our summation of all of our each individual observations minus our mean squared all over n minus 1, and then we take the square root last. Now, yes, calculating standard deviation is important. Knowing how to do that is important. However, the most important piece is actually knowing what it means. That is the most important. because we could use a calculator to find our standard deviation. That's awesome. So now we need to figure out how do we actually interpret these guys. So interpreting the standard deviation in context, that just means, remember, this is how far we deviate from the mean, how far we typically vary from the mean. So the number of pets that this elementary group has typically varies from the mean by 2.55 pets. It measures our typical distance of our values in the distribution from the mean. So our mean value is 5, so we usually go 2 over or 2 under. That's where the typical values usually are. They're typically there. Typically either 2 above or 2 below the mean. It typically varies 2 higher or 2 lower. So 2 more pets than 5 or 2 less pets than 5. That's where we're varying. That's our typical vary from the mean. So standard deviation should only be used for your spread when you have your mean is your chosen of center. Remember, we have our mean when we are not having any type of extreme outliers or extreme values here. So, additional properties of standard deviation. Standard deviation should always be positive. It should never be negative because we're going to be increasing or typically varying by a certain amount. Now, the standard deviation can be 0. Well, that just means that if we have 0 varying from the mean, that means we have all the same value in our data set. So that all observations are the same. Or we could say that there's no spread or variability within our data. There's no spread or variability within our data that's there. So standard deviation always has the same units of measure as the original variable measured. So if we're typically varying a certain amount of inches or feet or a certain amount of time, that is always going to be the same exact units. The standard deviation, because we're using mean, is non-resistant. Remember, it can't help but change due to those outliers, meaning that the fewer outliers, it will make it larger. So if you have outliers, think of it, there's a larger spread of data. Therefore, it's going to make sure that our standard deviation is larger if we have those outliers because our values are varying a further amount. The greater the standard deviation, the greater the variation is in the distribution. So if we have a big value, that just means that our values vary a large range of values. And the next one, in our next lesson, we're going to talk about IQR, which we'll talk about with box plots, box and whisker plots. So we're not going to talk about that one here. The only two I want you to focus on are standard deviation, which goes with mean, and then range. So we talked about mean, median, mode, which is pretty useless. And then we talked about range, how it's always a reliable set. But if we have outliers, we want to make sure that we don't use our mean or use our standard deviation here. So if you're watching this and you're finishing up notes, make sure you have the practice worksheet from me. You're going to practice your standard deviation, your mean, median, mode, and calculating all of those things.